In today's lesson, we're going to look at the graphs of other trigonometric functions. So we've looked at sine and cosine. Today we're going to look at tangent and cotangent and cosecant and secant. Tangent, it looks like this picture down here, the blue. You've got your x values, which are the angles, and the y values, which are the y values or the tangent values as you go along the unit circle. So if you put y over x for each point along the unit circle, then you're going to get tangent. For example, pi over 4, the x value is root 2 over 2, and the y value is root 2 over 2. So if you put root 2 over 2 over root 2 over 2, you get 1. And that's how you get the y value. For the tangent function, it is an odd function, and it's defined it's undefined at pi over 2 and every odd multiple of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, and so forth. Therefore, the period from negative pi over 2 to pi over 2 is pi. And here's what several periods look like. The domain is all real numbers except for those odd multiples of pi over 2. The range is all real numbers because it goes up forever and down forever. There are vertical asymptotes at those odd multiples of pi over 2 where it's undefined. And an x-intercept occurs at x equals 0 in every multiple of pi. So here's x equals 0, and then pi, 2 pi, negative 2 pi, and so forth. It's an odd function with origin symmetry. And at every odd multiple of pi over 4, the y-coordinates are negative 1 and 1. So what I mean by that is at negative pi over 4, we have the point negative 1, and at positive pi over 4, it's at 1. The y value is at 1. So graphing tangent, you first want to find the period, and here's how you do that. You use this thing right here. You've got bx minus c, which is the same in the same place as it was with sine and cosine, and you put that between instead of negative pi and pi, you put it between negative pi over 2 and pi over 2. Because that's where it's defined here. That's where we get a period. Then to identify the x-intercept, which in case just tangent was at 0, 0. That's what I'll often call, there's the x-intercept, or depending on if it's moved up or down, it could be the point of inflection, I call it, where it goes from being curved down to curved up. And then find the 1/4 and 3/4 points. Now, what are those? Here's the 1/4 point and the 3/4 point. That's what I mean. The 1/4 point is halfway between the left-hand asymptote and the point of inflection, and the 3/4 point is halfway between the point of inflection and the right-hand asymptote. Okay, so let's look at an example. Example 1, we've got the graph. It says to graph y equals 3/2 tangent of x plus 1/2. First of all, there is no amplitude, but there is an a value. Okay, so there's no amplitude because the amplitude determines where it maxes and mins, like in sine and cosine. And these don't max out. They go on forever. So there's not an amplitude, but there is an A value which will help us determine those 1/4 and 3/4 points. The period for this, we start with negative pi over 2 and bx minus c will go in between. So in this case, it's just x. And so that's it. Just negative pi over 2 to pi over 2. To determine the period itself, you would take pi over 2 and subtract off negative pi over 2 and get that the period is in fact pi. The asymptotes are just at these undefined points here on either end of the period. So they are at x equals negative pi over 2 and x equals pi over 2. And there will be more asymptotes, but those are the first two that we'll use as a guide to place more. There is a vertical shift on this graph. The plus d here, plus 1/2. So the vertical shift, it's going to go up 1/2 of a unit. The point of inflection. So on your notes that I've got written out, typed out for you, I use kind of a formula to find the point of inflection and the 3/4 and 1/4 points. But here I'm going to do it more just by graphing it. So whether you're a visual learner and learn by actually doing it, or if you learn better by using a formula, you've got the formulas on your notes to use, or in this case, I'm going to go through and do it more visually. So I'm going to go ahead over here and start graphing. Let's graph our asymptotes. They were at negative pi over 2 and pi over 2. Notice I know where pi over 2 is because here's 0 and here's pi. It's halfway in between. And so I can go another pi distance and put an asymptote at 3 pi over 2 also. Now the point of inflection is going to be halfway in between our asymptotes. So halfway between this one and this one is at the origin. Only there's a little bit of a difference here because of that vertical shift. So the vertical shift makes it move up from the origin 1/2 of a unit. Then the 1/4 and 3/4. So let's go put that over here. It'll be, the point of inflection is at 0, 1/2. And there will be another one in our next period that we're graphing here, right in the middle between the asymptotes at pi 1/2. Then the 1/4 point is halfway between the left-hand asymptote and the point of inflection. So it'll be at pi over 4. Now normally with tangent, it would be at pi over 4 negative 1. But because we've moved up a half a point, half a unit, then it's at pi over 4 negative 1/2. Or negative pi over 4 negative 1/2. Then for the 3/4 point, let's go ahead and put another one of these on here. Okay, so for the 3/4 point, it'll be halfway between the point of inflection and the right-hand asymptote. So that's at pi over 4. And normally for tangent, we would have pi over 4, 1, But since we've moved up a half a unit, it'll be pi over 4, 1 1/2. Now, we're not quite done with these 1/4 and 3/4 points, actually, because we need to take into account the A. So, the A's telling us that the distance from that point of inflection should be 3/2 or 1 1/2. So actually, this 1/4 point, we can just count it 1 1/2 from the point of inflection down. And then one 1/2 from the point of inflection up. And we could have done that before, or we can do it after, however it works for you. So the point of inflection is now -1/4, -1, and positive pi over 4, that was negative pi over 4, 2. And we'll go ahead and add on the other ones now. And so we can graph this, and when we graph it, it looks like that. It looks just like tangent before. Don't give me something that looks like this, okay? That's not correct. That would be counted wrong. It looks like the regular tangent from the other picture is just moved. The domain is all real numbers except every, and we can say, we'll put in the period here, so every pi starting with one of the asymptotes. It doesn't matter. I'm just going to choose negative pi over 4. Then the range is just all real numbers, negative infinity to infinity. So now we've graphed our first tangent. Let's graph another one. Doesn't hurt to practice. So again, there is no amplitude, but there is an A value, which we'll deal with here in a little bit. The period, start with negative pi over 2 to pi over 2, and we put our bx minus c in between. So in this case, it's just 2x. Now what we've got to do is we've got to solve for x, essentially. So we've got to divide everything by 2. And that actually gets us negative pi over 4 between negative pi over 4 and positive pi over 4. And that tells you your asymptotes. They're at negative pi over 4 and pi over 4. So I'm going to go over here and go ahead and graph some asymptotes. And the period here from negative pi over 4 to pi over 4 would be pi over 2. So back here where we've got the period, we could also go pi over 4 minus negative pi over 4 gives us pi over 2. So if I go another pi over 2, that takes me to one more asymptote in my graph as 3 pi over 4. So when you do your lab, I'm expecting you to fill in the whole graph that I give you, by the way. Okay. Next, is there a vertical shift? No, nothing's being added or subtracted, so no vertical shift. So what's our point of inflection? Well, for tangent, the point of inflection is usually 0, 0, and in this case it is 2 because it hasn't shifted up or down or right or left. So we're just halfway in between our two asymptotes, which will be at 0, 0. Then the 1/4 and 3/4 points. So we've got halfway between negative pi over 4 and 0 would be negative pi over 8. This would be negative pi over 8. And our y value is determined by the amplitude. Or not the amplitude, but the a value. And the a value was 3. So instead of negative 1, we'll be at negative 3. So our 1/4 point is at negative pi over 8, negative 3. And then our 3/4 point is halfway between 0 and pi over 4, or pi over 8. And instead of being at 1, because of the a value, we're going to be at 3. And I can come over here and let's see. We'll be at pi over 2, it looks like. And halfway between that at negative 3 and halfway between at 3. And now we can graph our tangent curves. And they don't have to be beautiful, but do not do that. It is not a line. It is a curve. So curve up a bit and curve down a bit. The domain would be all real numbers except the period, which we said was negative pi over 4 to pi over 4, so pi over 2. Beginning with one of the asymptotes. So I'm just going to start at x equals negative pi over 4 because that's the one on my graph. And then the range, again, is negative infinity to infinity. Cotangent is very similar to tangent, except for it's not centered at the origin. It's centered just to the right and left. The period is pi again, but this time the domain is everything except for multiples of pi. So your point of inflection would be at pi over 2, 0, and your asymptotes are at 0, pi, 2 pi, negative 2 pi, so forth. The range is all real numbers again. There's vertical asymptotes at those multiples of pi. An x-intercept occurs at odd multiples of pi over 2. So here's the first one at pi over 2. Then there's one at 3 pi over 2. Odd function with origin symmetry, and every odd multiple of pi over 4, the y coordinates are 1 or negative 1. Notice tangent went up like that. Cotangent goes down. So we've got 1 here and negative 1 there. Or we'd have, that would be pi over 4, 1, and 3 pi over 4, negative 1. Same type deal to graph a variation or graph cotangent, except the period is between 0 and pi instead of between negative pi over 2 and pi over 2. Notice the period between 0 and pi. So let's look at an example. Again, there is no amplitude, but there is an A value, which we will use later on when finding the 1/4 and 3/4 points. The period is between 0 and pi, and we put in bx minus c, which in this case is just pi over 2x. To solve this, then we need to divide everything by pi over 2. So we've got 0. X is between 0 and 2. So this time we're not even dealing with the regular trig axis, we're just dealing with 0 and 2. So our asymptotes will be at x equals 0 and x equals 2. And then there will be one at negative 2 also. And the period would be 2 minus 0, or 2. There's not a vertical shift. To find the point of inflection, we just go halfway in between our period. So halfway between 0 and 2 is at 1. And our y value will be determined by that a. And the a was 1/2. Or no, it won't. That's the 1/4 and 3/4. So it's actually just 1, 0. Then the 1/4 point, halfway between 0 and 1 is 1/2. And we're starting up and going down. So our a value was 1/2. So instead of at 1/2, 1, we're going to be at 1/2, 1/2. And then the 3/4 point will be at 1.5. And instead of 1.5, negative 1, we'll be at 1.5, negative 1/2. And then we can graph our curve. And I'll go put another period over here. The domain will be all real numbers, except every period, and the period is 2. Beginning with an asymptote. So our first asymptote is, I'm going to just use x equals 0. And then the range, negative infinity to infinity. Now we're going to talk about secant and cosecant, we know that cosecant is 1 over sine and secant is 1 over cosine. They're the reciprocals. And that is taken into account when we're graphing. So cosecant is the reciprocal of sine. So we actually use sine to help us graph cosecant. The pink curve here is the sine curve. And the green is the cosecant curve. So notice with the sine curve, to create the cosecant curve, the asymptotes are everywhere that the sine curve has this point of inflection, this where it crosses the x-axis in this case, but depending, not necessarily if it's got a vertical shift, but wherever it crosses the x-axis here are your asymptotes. And then at the top and the bottom of the valleys, we flip and make a U. So this U becomes this U. And at the bottom, this U becomes this U, and so forth. The period is the same as with sine. It's 2 pi. The domain is all real numbers except every half period, which in the case of just straight cosecant is every pi. So every half of a period will have an asymptote where it's undefined. The range. So the range here, notice, we're just looking at the green. It's coming from negative infinity and going up to negative 1. And then it's starting again at 1 and going up to infinity. So we would write the range as negative infinity to negative 1, including negative 1, unioned with 1 to infinity. The secant curve, very similar, except for it is the reciprocal of cosine. So you do the same thing, except for with cosine. Periods pi or 2 pi again. This time, your domain is all real numbers except starting at pi over 2 and every odd multiple. The range is the same, and then the vertical asymptotes are at those undefined points. Example 4 is just asking us to use the graph of sine of x plus pi over 4 to obtain the graph of cosecant of x plus pi over 4. So if you'll notice, here's where it's inflecting up and down. And so at those points where it crosses what we've graphed pink there, or the x-intercept in this case, we have asymptotes. And this is not an asymptote, so I'm going to get rid of it. And then we just take, and at the top of this hill, we flip it and make a U like that. At the bottom of this valley, we flip it and make an upside down U like that. And we could do a piece of 1 here and a piece of 1 there. And so that is the graph of cosecant of x plus pi over 4. So let's look at some examples of cosecant and secant. So the first one, we're going to graph y equals 2 times the cosecant of x minus 1. It asks for the amplitude. There is not an amplitude because we don't have a max or a min. It goes to infinity and negative infinity to the range. But there is an A value, which we will have to take into account. The period goes along with sine. So what we're actually doing here is we're actually going to graph y equals 2 sine of x minus 1. And then we'll use that to flip and make cosecant. So the period is 2 pi over b, just like with sine. So we've got 2 pi over, and b is just 1. So the period here is just 2 pi. The vertical shift, there is a vertical shift of 1. And it's negative 1, so down 1. Got to charge my pen. Hang on. Okay, so the vertical shift, my pencil's not working. Okay, vertical shift, down 1. Phase shift would be C over B, but there's not a C, so we don't have a phase shift. So let's start graphing this a bit. We know that sine normally starts at 0, 0, but there is a vertical shift down 1. So we're going to go down to 0, negative 1. So we'll go ahead and make our 5 points just like we do with sine and cosine. So start with the period divided by 4 is pi over 2. So your first point was, actually in my case it's going to be my middle point, 0, negative 1. Then the second point is pi over 2 over. So let's see. Here's pi, so halfway between is here's pi over 2. And with sine, it would normally be at negative, or excuse me, if we were graphing normal sine, it would be here. But because we have an amplitude of 2, then we've got to go up 2 from there. And there we go. And then the other way, we're going to go down to at negative pi over 2. So that's at 1, and negative pi over 2 is at negative 3. And then we go back to the center, which is negative 1 for the y values. And that'll be at pi and negative pi. Okay, so here's what the sine curve would look like. And that we're going to use to help us graph the cosecant curve. So the asymptotes will be everywhere where we've got an inflection there. So at negative pi, 0, and pi. I only asked for 2 of them, so. And then, so now we can graph it, and we just start there and do our U. And, you know, don't just do this or something, okay? Make it fill in its space, getting close to the asymptotes like it would make sense. The domain then is all real numbers except every half period. Our period was 2 pi, and so it's a half a period. It's from there to there, pi, beginning with, I'm just going to use one of the asymptotes, x equals 0. Then the range starts from negative infinity and goes up to negative 3. Then unioned with 1 to infinity. Okay, and now we've got our y equals 2 cosecant of x minus 1 graphed. Let's look at one more example for secant. Y equals 2 times the secant of 2x. Again, there's no amplitude, but there is an a value of 2, and so we'll take that into account. The period is the same as with cosine. Recognize that we're going to be graphing y equals 2 cosine of 2x and using that to help us. So the period is 2 pi over b. B in this case is 2, so the period will be pi. There is no vertical shift, and there's no phase shift because there's no C value. So now we're just going to graph, finding our 5 key points. Normally, cosine would be at 0, 1. But since our a value is at 2, then we're going to start at 0, 2. Let's do our period divided by 4 so we can find our 5 key points. So our period was pi. So period divided by 4 is pi over 4. So after we've got 0, 2, then we're going to go pi over 4 to the right. And let's see, where's pi over 4? Well, here's pi, so this has got to be pi over 2, so that must be pi over 4. If it helps you, you can mark it on there. And so here must be 3 pi over 4. We're probably going to need that. Okay, so normally we'd be at pi over 4, 0. And since there's no vertical shift, then in fact that's where we are. Then we go another pi over 4 to the right. That takes us to pi over 2. And pi over 2, we're going to go down because of the a to negative 2. Another pi over 4 takes us to 3 pi over 4 and back to 0. And then we could go, another pi over 4 takes us to pi 2. Okay? So now we can sketch in our cosine curve, and we can keep going over to the left here, following the same pattern. Then our asymptotes will be where we cross the x-axis in this case. So there will be one at negative 3 pi over 4, negative pi over 4, pi over 4, and 3 pi over 4. So I'm just going to put pi over 4 and 3 pi over 4. I'm just going to list two of them. And now we can graph our secant. So at this valley, we'll flip and make a U. At the top of this hill, we'll flip and make a U. We could put another one here. Go ahead and fill in our graph. And we can put a piece of one there and there. So the domain is all real numbers, except every half period. So the period was pi, so it's every pi over 2, and you can see the distance here is between the asymptotes is pi over 2. Beginning at one of the asymptotes. I'm just going to use x equals pi over 4. And last, the range. Going from negative infinity up to negative 2. And then starting back at 2 to infinity. And so that finishes up our examples. I think the rest of these slides are just looking at the 6 different curves. There's sine, cosine, tangent, cotangent, cosecant, and secant. Okay.